The periodic table of elements is a carefully designed chart that consists of all the chemical elements known to science. The table is divided into 2 major groups and 10 different subgroups. The 2 major groups are metals and nonmetals. These are our basic classification for each element. Within these 2 groups are several subgroups. The different subgroups within the periodic table are metalloids, halogens, noble gases, other nonmetals, alkali metals, alkaline earth metals, lanthanoids, actinoids, transition metals, and post-transition metals. Each group except the metalloids fall into 2 separate and different characteristics of metals and nonmetals. The metals are often good conductors of heat and electricity. Metals are often malleable, meaning they can be beaten into thin sheets without breaking. Metals are also ductile, meaning they can be stretched into wires. Finally, metals are solid at room temperature. You may find some examples of metals in your daily lives. They are found in wires, heating devices, and even in your mobile cellular devices. Nonmetals, on the other hand, are different from metals. They are poor conductors of heat and electricity. They are also brittle, meaning they can break easily, and they are not malleable, nor are they ductile. Most nonmetals are not solid at room temperature. There are many examples of nonmetals that can be found in your everyday lives. For one, the oxygen you breathe in is not a metal. This means that it's a nonmetal. In fact, many nonmetals are gases. Metalloids are a special group of elements. They have properties of both metals and nonmetals. They are usually solid at room temperature and can conduct heat and electricity, but they are fairly brittle and some are not ductile or malleable. As mentioned earlier, the different subgroups are all part of 2 major groups, except for the metalloids. These 2 major groups are the metals and nonmetals. The noble gases, halogens, and other nonmetals all fall under the classification of nonmetals. The alkali metals, the alkaline earth metals, lanthanoids, actinoids, transition metals, and post-transition metals all fall under the classification of metals. Now let's take a closer look at the properties of each element, specifically the reactivity. It should be noted that the reactivity and stability of an atom and element depends on the amount of valence electrons. These are the electrons on its outer electron shell. Atoms and elements with 8 electrons on its outer shell tend to be more stable than others. If you look at a periodic table, you would see that as the elements go across, the amount of electrons on the valence electron shell slowly start to increase. The atoms and elements to the far right of the table all have 8 electrons on their outer valence shell. This makes them the most stable. It should also be noted that all the elements on the far right are all noble gases. Because they have 8 electrons and they are stable, these elements do not react, making them inert. The other elements and atoms have less than 8 electrons on their outer shell, and so they must react with other elements and atoms that have less than 8 electrons on their outer valence shell in order to remain stable. This is because they want to have 8 electrons on their outer valence shell. This is called the octet rule. Now that we have looked at the properties of each group, let us look at the names of each group and understand why they have been given such names. Let's begin with the basics. Metals are called metals because they consist of properties found in metals. Nonmetals are named under the circumstances that their properties are the exact opposite of metals. Now let's take a look at the subgroups. Metalloids consist of properties of both metals and nonmetals. The term metalloid refers to any element whose properties are intermediate between or shared by both metals and nonmetals. Halogens were named under the circumstances of that they were extremely reactive nonmetals made from acidic compounds. In chemistry, any element that consists of these properties are classified as halogens. Some of these elements include fluorine, chlorine, and iodine. Noble gases were named under the circumstances of that they are gases that are unreactive. They are inert and will not react with any other element. The term noble gas may be referred to the definition of noble, meaning having fine quality. The group other nonmetals are named because they do not have the qualities of metals, nor do they have the qualities of halogens or noble gases. Alkali metals were named under the condition that they have alkali properties. This means that they become neutralized through corrosion. This is often seen in elements such as lithium, sodium, potassium, and any other alkali metals. Alkaline earth metals also follow the properties and the definition of alkali and alkali metals. They often corrode over time and in the process become neutral. Lanthanoids and actinoids are extremely reactive metals. They fall between the alkaline earth metals and transition metals. These are very reactive because they all only have 2 electrons on their outer shell. The origins of their names are unknown. Transition metals are seen in the center of the periodic table. These are the metals that tend to show different amounts of valence electrons and tend to form compounds. This is where they get their name from. Post-transition metals fall between the transition metals and metalloids. They are called post-transition metals because they are the last of the metallic elements that keep all of the metallic characteristics without sharing the non-metal characteristics. To review, there are 2 major groups of elements and 10 subgroups. Nonmetals are brittle and dull, while metals are malleable and ductile. Metalloids have characteristics of both metallic and non-metallic elements. Elements follow the octet rule, meaning they need to have 8 valence electrons to remain stable. The less valence electrons an element has, the more reactive and unstable it is. This is the periodic table, the groups, and properties.